Hello and good day to you wherever you are in the world and whenever you're watching this video. So the purpose of this video, or rather the reason it came about, was on the back of a query that I received by from one of my my LinkedIn contacts. So the contact had set up a EVPN environment. So in case you aren't aware, FortiGate firewall support full VXLAN, multi-protocol BGP signaled VXLAN tunnels, right? Meaning you don't have to stitch up VXLANs manually. You can use multi-protocol BGP to do that in the same way as you can on a enterprise data center type switch or enterprise type router. So the challenge that the contact was having was that his setup all looked fine from a configuration perspective, but his branches could communicate with the hub, but they couldn't communicate with each other, all right, even though all the routes were there, seemingly. Now, this topology doesn't emulate his topology exactly, but the net result is the same, all right? So in his topology, he had a router in the middle here, and he had the FortiGates connecting to that router like a pseudo WAN. So I've got them directly connected, but as I said, the net problem remains the same, and the net result remains the same. Now, what I've chosen to do here is use BGP loopbacks for my reachability, in other words, for my BGP peer adjacency. And I've also used another loopback for my EVPN signaling. Now, I could have used the same one, but I like clear demarcation. So just from a informational perspective, why do you use a loopback for BGP as opposed to the physical links? Well, imagine I had a number of different links and different paths between branch 1 and hub, right? What would happen if I only ran BGP on one of those links and that link went down? BGP would go down, right? Which meant that I would then have to have multiple neighbor statements across multiple different IP addresses. And then you've got the challenge of, which one is chosen, and it just becomes a complexity nightmare. Whereas a loopback address is always available. It's a virtual interface. It's always up. And as long as you've got routing reachability between loopbacks, and ideally you want to use some sort of an IGP like OSPF or ISIS to do that. In this case, because there's only 3 devices, I've chosen to use statics, but it's irrelevant. The net result is exactly the same. Now, because the BGP loopback is being used, we use the update source, all right? So basically the next hop is always going to be the BGP loopback or the root origin, which means that in order to have branch 1, which is on 18.112, and branch 2, which is on 18.113, establish a VPN tunnel, they need to be able to reach those individual IP addresses. So if I was to configure that statically, all right, so if we just take a manual approach, which is not scalable, all right, but if you've only got 2 devices and you just want to stitch them up using VXLAN, this is a perfectly valid way of doing it. But in a static way, I would typically use my outgoing interface as my source, all right, and then I would use the remote IP address of my neighbor as the destination, right? It's quite simple, and it's reflexive on this side. And I set up the VNI, so the VNI represents the VLAN. The name can be anything you want. For me, I like to keep things consistent, so VLAN 200 there, VNI 200. But as I said, you could call this Donald Duck, Mickey Mouse, HR, engineering, whatever you want, whatever makes sense to you. Now, in this instance, the tunnel will come up quite easily because it's got direct reachability. That should be quite obvious. But if we come back to this topology here, for 18.112 and 18.113 to communicate, they not only need reachability, they need to be able to get to each other, right? So, just having these routes in the BGP routing table is insufficient if the next hop that resolves for their next hop is not in the routing table, and in this case rather, it will be the BGP loopback address, because the BGP loopback address is the BGP update source, not the physical links. So let's have a look at that. So if we come along here to the WAN, we look at the BGP routing tables as they exist right now. So if we do a get router info routing table BGP, so I can see those routes. Now, if I do a show router BGP, you can see here I'm actually publishing that 17.111 as a network. I'm also publishing the actual physical addresses of the physical links, but you'll notice that they weren't in the BGP tables, right? And we'll get to why that is right now. Just for context, for the EVPN, there's a couple of things you need to have. All right, this is the hub, so it's going to be a route reflector both for the BGP IPv4 as well as for the EVPNs, and it needs obviously the VPN v4 extensions, which is the multi-protocol element of it for the signaling. If I had multiple links, obviously I'd have multipath there. I've only got a single link, but I put that on anyway, and recursive next hop lookups. So if I do a show system EVPN, this is where you set up your actual route descriptor, and you import and export route targets. This is identical for those of you that are familiar with MPLS or VPLS. This is identical to the way you do that. And show system VXLAN is where I actually define my my VXLAN endpoints. Right now, you define that, but it gets signaled dynamically. So if we go across to my branch here, and I do a get router info routing table BGP, again I'm only seeing that, and same again on branch 2. Get router info routing table BGP. Excuse me. Now, if I look at the IP addresses here, diag IP address list, I can see that my VXLAN is that 40.3, and on this side, diag IP address list, it's 40.2. So let's see if those two can ping each other. Execute ping dash options source 192.168.40.2, and we'll do the same on the side. Ping dash options source 192.168.40.3. So execute ping 192.168.40.2. Can't ping that, right? Because that's the other branch. Can I ping .1, which is the hub? Yes, quite happy. Come along here, execute ping 192.168.40.3. No joy there. Can I ping 1? Yes, I can ping 1. Right, now let's go back to that BGP. I can't ping that because I am not resolving for that next hop. That next hop being the 17, which is the BGP loopback source. Remember here, if I do a show router BGP, my update source here is my BGP interface. So if I come to the hub and I do a get router info routing table all, the hub can see 17.111, 17.112, and 17.113. But note, these are statics. And a static is always going to have a lower metric than a BGP. So it's not going to, BGP is not going to distribute those because it's got a lower metric, right? So if I come along here, get router info routing table all, okay, I can see my next hop 17.112, which is the hub. I can see myself, but I can't see 17.113. And same again here, get router info routing table all. This can see itself, which is connected, and it can see the hub, which is 17.112, but 17.111 is missing. All right. So again, even though the EVPN loopback addresses are there, we can't resolve for their next hop because the path to get to each other is via the 17.1.1.1.2, which is the hub. So what I've got to do here is I come along to the hub, come down. I could do this via CLI, I'm just being lazy. All right, come along here and I say redistribute statics and I apply that. All right, now obviously it's going to take a few seconds for that to update, so we'll just be patient. The route will come straight across, but the EVPN signaling is going to take a few seconds. So if we do that get route table, let's do the BGP again. So now branch 1 can see 17.1.1.3, and if I come along here, branch 2 can now see 17.1.1.1. So if I do a get router info BGP EVPN, all right, sorry, network, you can see here that we already knew that. I should have shown you that earlier, sorry, but it already knew from an EVPN perspective that these were the paths to be able to get to their next hop. But how did we resolve to there? We needed this route in here. So now if it's updated, we should be able to ping. There we go. So now I can ping 40.2, and if I come along here, this one should be able to ping 40.3. Okay, so hopefully that made sense. The idea wasn't to have this as an elongated video on EVPNs and how to set them up. There's a perfectly good document that I will post when I post this video. I will attach that document. So just follow those, but remember that no matter what you do, your BGP must be consistent. The BGP is what the EVPN is relying on for its end-to-end signaling. If your BGP is not working correctly, your EVPN is not going to work correctly. So thank you very much again for your time.